5.20. You know what? Come over here. Let's dance with you. Okay, let's see what is required of us. You can pause the video and check it out. We're doing 5.20. We're basically printing out our prime numbers. Okay, so here's what I'll do. Just like before, I'll have a variable called is prime, which will tell us whether or not a number is prime. Yeah, the thing is, there's something I had to take care of. Anyways, let's continue. Now we wanna have count the number of prime numbers we've displayed so far. Boom, 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 boom. Oh, just like before, what else we want is a outer for loop. And I'll simply call my variable number. That is basically the number we wanna determine whether or not it's prime. So we're going all the way up to 1,000 inclusively. So we increment our number. Unlike before, or again, I wanna initiate at first. I wanna say my number is prime. Okay, unlike before we used a for loop and the break statement in order to exit our for loop in case we came across a divisor of a current number we check in. Okay, so here's the deal. What I'll simply do is to have another variable, another short variable. I'll call it J. I'll initiate it the 2. Okay, and then I will use a while loop, which will simply check if J is less than or equals to I. You know what? Before, what we did is we went from 2 all the way up to a number we're looking for -1. However, we realized that that way of doing things is more inefficient. So what we then did is we decided, do we go halfway through? Okay. However, there's a solution which is even more sufficient than that, and that is to go all the way up to the square root of a number you're actually looking for. You can research this on your own, but it works. Okay, you can never find a number that divides. Given a number n, you can never find a number that divides n that is actually above its square root. I don't know if that makes sense or if I chose the right words. Anyways, let's continue. Okay. Okay, so while this is the case and the number is prime, we'll keep continuing. So what we do is we simply check if number mode. In fact, I should have chosen something more descriptive here. Divisor. Yeah, that will do it. If that number is a divisor, what we'll then do, we will update our is prime to false. That should be it. Okay, now it's time we determine whether or not we print our number, and we'll do that the same way we did on our previous solution, and that is to simply increment our count variable first, and then system.out.print. We print number, give a space. Again, this part here tells us where to display our prime number. Whether we should display it on the current line. After we've displayed our number, whether we should continue on the current line or we should proceed on the next line. Okay, we need a question mark here. You go \n, otherwise we'll leave only one space. Yes, that should be it for the solution. Let's hit the run button and see what we get. Oops, that was so dumb of me. Let me see, where could I possibly have made a mistake? Boom, 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 boom. Oh, it seems like I did not increment my... It seems like I didn't increment my divisor. Okay, so let's do that. Divisor. Done. Okay, see you guys on the next solution. Again, please make sure, folks, you attempt these exercises. You don't want to keep watching, because you won't get not even a single thing if you do that. See you on the next tutorial, you guys.